Hello everyone, welcome to another video on differential calculus. I'm still looking at past exam papers, and today I thought this would be the last video on rules of differentiation and first principles, but I've decided to break it down into two because it's too many marks and it would stretch the video to 60 minutes or so. So I'm starting on this about 24 marks. That would actually take us to about 30 or so minutes to go through. So, and I'm focusing on questions 1 and 2 only, because these involve first principles, rules of differentiation, and like I said in the previous video, just a bit of application on the last one there on this one here. All right, so question 1 says f of x equals minus 4 over x, and we're supposed to first of all determine f prime of x using first principles, and then we have to explain why the derivative is positive for all values of x, and then we move on to the 1.3 and 1.4, and then we come to question number 2. We're going to do only differentiation here, but by applying rules of differentiation. Right after this, in the next video, I'm going to repeat this kind of stuff, but it's going to be different items involved. As you can see, this question over here, first principles and then equation of a tangent, but presented in a very different fashion. And then we have these two questions there basically, and that's the last one there on application. So I felt I should go through these two in two separate videos, and then that will be the end of my work on first principles and rules of differentiation. And then I will move to university stuff, like I promised, product rule, quotient rule, and chain rule, techniques of differentiation. Then I'll come back to grade 12 stuff and talk about applications of differential calculus, dealing with graphs and also optimization. All right, so let's start then. We're starting on this question here, and we're starting on this question, and it's just basically rules of differentiation, first principles first, and then rules of differentiation. So let's start question 1. So question 1, still on rules of differentiation. Let's call this page 1. 1.1 says we are told that f of x is equal to minus 4 all over x. Actually, the entire of this question is based on this function. So let me write it up there. F of x is equal to minus 4 all over x. And the first part says we must differentiate this function with respect to x. So we are going to say, therefore, f of x plus h will be equal to minus 4 all over x plus h. If you recall, in one of the videos, I did cover questions involving rational functions like this one here, in the form of p over q, where p and q are, of course, numbers or integers, and the denominator is not equal to 0. So basically, we're dealing with rational function here. Let's move to the formula then. F prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting these two expressions into the formula, we have limit as h approaches 0 of minus 4 over x plus h minus, remember I told you to always put brackets there, minus 4 over x all over h. And I'm going to take h to the other side. This is going to be limit as h approaches 0 of minus 4 over x plus h plus, remember that minus sign must change. When you multiply minus by minus, you're going to get positive 4 over x. And I'm going to write this one as follows, like this, and then times 1 over h on the other side, like so. And here I'm going to do the simplification of these two fractions. So this is going to be limit as h approaches 0. The common factor there is going to be, the LCD, the lowest common denominator, is going to be the product of the 2x times x plus h. And then I'm going to divide this expression here into that. The answer is x, and we have to multiply x by the numerator. So this will be x times minus 4 plus, then I'm going to say x into that expression in the denominator. The answer is x plus h, and then I'm going to take x plus h multiplied by 4, so 4 times x plus h, like this. And then we are supposed to say all this multiplied by 1 over h, right? And then simplifying the numerator there, we have limit as h approaches 0 of minus 4x plus 4x plus 4h all over, if you like you can bring the h down there now, x plus h times h, bringing the h down there. Simplifying the numerator, obviously you can see these cancel, so we have limit as h approaches 0 of 4h in the numerator all over x plus h times h, and you can see this h cancels that h there. We are going to have this as limit as h approaches 0 of 4 all over, expand this denominator here, you're going to get, if you expand the denominator, you're going to get x squared plus xh, like this. Now you can see as h approaches 0, xh will approach 0, and your final solution is going to be 4 all over x squared. This is the final solution. This question, if you see here in the question paper, it's actually 5 marks. The 5 marks are distributed as follows. You're going to have 1 mark for that expression, 1 mark for substitution of the 2. Now by now you should see 1 mark for simplifying that expression there at that format there at that stage, and then 1 mark for the common factor cancellation, and 1 mark for the final answer. So that would be 5 marks. This is how I would distribute the 5 marks. Right, let's move on to the next question, 1.2. 1.2, if you check here, it says explain why f prime of x is positive for all values of x. Now, if you notice here, f prime of x is actually 4 over x squared. And whatever value of x is, obviously x cannot be equal to 0, because if x equals 0, the whole function is undefined right from the start there. X is not permitted to be equal to 0 there because it's dividing. And whatever value of x you have there, as long as it's a real number, when you square it, it's going to be positive. And therefore, this can never be negative, because the numerator we know is 4 is a positive number, and the denominator can never be negative, and therefore the quotient can never be negative. That would be the explanation. So let me write it down, 1.2. So 1.2, and this is page 2. We are saying 1.2, we've said f prime of x, shown here from first principles, 4 over x squared. And then you're supposed to say x squared is positive for all real values of x, and of course we know that x is not equal to what? 0. And therefore 4 over x squared will be positive for all real values of x, excluding of course x equal to 0. That would be the explanation. This is what this question is demanding you to explain for 1 mark. So where is that mark awarded? Well, that mark is awarded, this is just a follow-up from there. So that mark is awarded for this statement here. That's where you're going to get that 1 mark there. Right, and this just follows from there because we know 4 is positive in the numerator there. Right, 1.2 done. Let's move on to 1.3. 1.3, here it is. If you check here, 1.3 says what does your answer to question 1.2 mean in terms of the graph of f? So let's just write it here, 1.3. 1.3. Remember, f of x, we are told, is equal to minus 4 over x. Now we have shown that f prime of x is equal to 4 over x squared, and this from 1.2 is positive. The meaning of this is that that function is increasing for all values of x, because the derivative can never be negative. In other words, the tangent to the graph has positive gradient. That tells you that f of x is increasing for all values of x. So this means f of x, which is equal to minus 4 over x, is increasing for all real values of x, and obviously we must constantly say that x is not equal to 0. So this is the critical part. They are looking for that, and it's 2 marks. What does it mean? So they are basically looking at the fact that you are saying this is an increasing function, is increasing for all real values of x, and x is not equal to 0. You are going to be given, remember you have already been given a mark for saying that that is positive, but if I were to distribute these 2 marks, I would say this is what it means, and then because it follows from there, I would give a mark for that also. There is your 2 marks there. Right, 1.4. 1.4, if you check here, 1.4 talks about equation of a tangent. Find the equation of a tangent to the graph of f at a point where x equals 2. We've done a similar one. This is why going through past exam papers is critical, because you tend to see which questions are frequently presented in question papers. And so when you're revising, you spend more time on these things, make sure the concepts are well mastered. All right, so let's go through this then. So 1.4, the last one on question 1. 1.4, we are told f of x is equal to minus 4 over x, minus 4 over x. And then because we're required to determine equation of a tangent, we're going to say therefore y equals f of x, which is equal to minus 4 over x. Why do we do this? Because we are told that we're supposed to find a point first, because we know the value of x is 2. What will be the value of y? The value of y will be minus 4 all over 2, and that's minus 2. Substituting in there and there, obviously trying to shorten there because of space. So that tells you that we have x is 2, the value of x is 2, comma, the value of y is minus 2. Let me just clean up here a little bit. The value of x is 2 and the value of y is minus 2. X is 2, y minus 2, like this. And let me call this value of x here. My pen is misbehaving a little bit there. Let's call this one x1, and let's call this y1. From the previous video, you should remember now that we next have to work out what we call gradient of a tangent. And what is gradient of a tangent? Derivative. We have already differentiated the function, so let's call this page 3. We already know. Next, we're supposed to say m tangent. M tangent, we know this is going to be f prime of x, and we are told we actually have determined this one to be 4 over x squared. And then we're supposed to say therefore at x equals 2, at x equals 2, at x equals 2, how do we determine the gradient? Let me just clean up this one a little bit here. Right, I'm not happy with that, but yeah, let's carry on. So at x equals 2, what is m tangent equal to? M tangent at m equals 2 is going to be f prime of 2. And what is f prime of 2? Remember, you coming here and then you must come here. 4 over 2, and that has to be squared that. So this is 4 over 4, and the answer is 1. So that is the gradient of our tangent. So now we are supposed to go to Points law formula, which says y minus y1 equals m, and then x minus x1. What I told you in the previous video is that you must always use brackets here when you're substituting the values there. So I'm going to write this as y minus, open bracket, close. My m is 1 from here, you can see. And I'm going to use a square bracket here, x minus, and I'm going to use round brackets there to take care of the value of x. Let's perform the substitution there. We know x is 2 and y is minus 2. So y is minus 2. and x is 2, like so. Let's simplify. On the left hand side, you're going to have y plus 2 is equal to, on the right hand side, you just have x minus 2, because 1 times everybody here is just what you have there. And then I take subtract 2 from both sides, you're going to get y equals x minus 2 minus 2. This gives you y equals x minus 4. This is the equation of a tangent which the question requires us to find. So this is how you'd go about this. Repetition is critical in the process of learning, teaching and learning. So that's why I'm repeating these things, so that someone may just watch these videos and they are ready for exams. How are the marks distributed? We have, for this question, if you check here, we have 4 marks. If you check here, we have 4 marks. These 4 marks, I'm going to try and show you how these 4 marks should be distributed, and that's my choice of distribution of these marks. Someone else may decide to distribute these marks differently. But the 4 marks, according to me, this is how I would distribute the marks. I would give a mark for that number there, value of y, and then I would give a mark there for gradient, and I would give a mark there for substitution, and I would give a mark for the final answer. So the value of y, the value of gradient of the tangent, remember this m is m tangent, and substitution obviously, and the final answer. So that would be 4 marks. This marks the end of question 1. Now let's look at question number 2. So question number 2, a different one now, from another exam paper, and I've added the last one there. This is now based on rules of differentiation. As you can see there, we're supposed to use rules of differentiation. All right, so let's look at number 2, number 1. So this is going to be page 4, question 2 and 2.1 basically says that we are supposed to determine dy dx if y is equal to 2 square root of x, and then minus x power 6 minus x power 5, x power 3 actually, all over x power 5. So that's x power 3 up there. Let me fix it. X power 3 there, and I'm coming back there to fix it just now. So this is the question we're dealing with. If you can see there, yeah, you can. So it says determine or find dy dx if y equals 2 root x minus x power 6 minus x power 3 all over x power 5. And then we are going to do the last two. So this is power 3 there, and we're supposed to work out dy dx. So now here is what I want to suggest you to do. We simplify this part first, this part and that part. So here it's going to be 2x power half. Remember, I told you that square root means power half. In the previous videos, I've explained this. All right, minus, here I'm going to introduce another set of brackets here. Be careful when you're dealing with fractions and the minus sign. I'm going to have to simplify whatever it is here and then subtract. So inside here, I'm going to do what we call term-wise division. So it's going to be x power 6 all over x power 5. Then minus x power 3 all over x power 5. I'm going to write that expression there. I told you that this process here, what I'm doing inside here is what we call, let me write it up there. This is known as term-wise division. It's only allowed if there's a plus sign there or a minus sign. Division, multiplication, you don't do that. You divide only once, like I said in the previous video. So now let's simplify this. So this is going to be obviously 2x power half, and then minus this, obviously is going to be x, because 5 minus 6 minus 5 is 1, x power 1 there, minus here, if you check 3 minus 5, it will be x power minus 2. Now let's remove these brackets here. You're going to get 2x power half minus x plus x power minus 2. So you see, if you did not put these brackets here, you would have messed up that sign there. Now I can perform the differentiation. So therefore, dy dx is going to be equal to, using rules, multiply by half there, and then x power half, reduce that power by 1. And then derivative of x, like I showed you last time, is 1. So we have minus 1 here. And then plus, differentiate this part here, it will be minus 2, and then x power minus 2 minus 1. Simplifying this, obviously you can see this cancel. So I have x power minus half, because what half minus 1 is minus half. And then I have minus 1, and then I have minus 2x power minus 3. Rewriting this, respecting the format in which the question has been presented, the first step is 1 over x power half positive. Remember rules of differentiation, rules of exponents. When the power is negative up there and you bring it under the division sign, the negative sign changes to a plus sign like this. And then the 1 stays the way it is, but I'm going to bring this one to this side first. So that will be minus 2 all over x cubed, and then minus 1 at the end there. And this part here must be rewritten as 1 over square root of x. Remember, power half is square root. And then minus 2 over x cubed minus 1. So this would be the final solution if we were to respect the format in which the question has been presented. But otherwise, mark distribution, like I have told you in the previous videos, they are not very particular when it comes to these last two steps. So how are the 5 marks distributed? This is how I would distribute the 5 marks. Firstly, coming here, 1 mark, 1 mark, 1 mark. So it means the process up there is only 2 marks. Right. So where are we going to award the 2 marks? Well, I'm going to put 1 mark for expressing that square root of x as x power half, and then 1 mark for simplifying this part to get these 2 terms here. So that would be another mark. So altogether, you have 5. Right. Right. Let's move on to 2.2. Question 2.2, that will be our page 5. Question 2.2, if you can see here, 2.2, it says the differential operator derivative with respect to x of this expression here. That's capital D, like I've said in the previous videos. It represents differential operator, basically saying differentiate this with respect to x. So we're only focusing on first derivative, because the power, the numerator, the power in D there is 1. I hope, let me just put what I'm trying to say on a different page so you understand. For those that are seeing this video for the they've not watched the previous videos, I have said in my previous videos when I was explaining this, I've said if you have D with respect to x of whatever expression here, it means that's a first derivative, because the number there is 1, which we don't write. But if we want a second derivative, we're going to write it like this, and then put 2 there. It means you must differentiate and then differentiate that expression which you obtained after differentiating. Let's just give an example here. Suppose you had x power 5 here, and so we suppose x power 5, this would be, if you remove this expression, will be 5x power 4, basically using the power rule. If you had the same expression x power 5 like so, the answer would be differentiate the first time, which is 5x power 4, remember, but this now becomes d with respect to x. Now we've differentiated the first time, the 2 has gone to 1 now, which we don't write, like I said, and then we must perform the differentiation. Let me rewrite this so that you clearly see it. I'm saying this would be equal to derivative with respect to x of 5x power 4. So you'd move from there to here, with the power of 2 there now changing to 1, which we don't write. But now what does this mean? It means now you must get rid of this, and you say 5 times 4, open brackets, 5 times 4, x power 4 minus 1. So this would be 20x power 3. Please take note of that. Right, just to remind you there. But now let's move on to this part here now. So number 2.2, this is now page 5. Page 5. Question 2.2. What does it say? Derivative with respect to x of x plus a all squared. If you remember this, I've explained that. Simplifying this or expanding it, you get x squared plus 2ax and then plus a squared. Now we're differentiating with respect to x, and therefore everything else must be treated as a constant. So this is going to be derivative of x squared is 2x. Derivative of this part here, we differentiate only x, which is 1. So 1 times 2a, it will be plus 2a. That one is a constant, there is no x there. So derivative of a constant is 0, and therefore this is our final solution. Right, please take note of that. How are the 3 marks distributed? Well, you have 1 mark for expanding that, and then 1 mark for that, and 1 mark for that. That will be 3 marks. You can see here we have 3 marks there. You can see it's 3 marks, that one there. Now let me look at the last one, which I added 4 marks. So the last one is number 2.3. 2.3. It basically says we're supposed to find dy dx if y 2 actually says 2x squared y. Let me rewrite that. 2x squared y. So we have 2x squared y, and we're told plus 4 is equal to 3 cube root of x, or 7. Quite involving, but yeah, we do have these questions come up many times in past exams. I mean, in exam papers. So let's quickly go through this. We're supposed to determine dy dx, and it's 4 marks. Step number 1 is to solve for y. So we're gonna now say 2x squared y plus 4 is equal to, check this out how I'm gonna write it, 3x power 7 over 3. If you have attended my previous, you watch my previous videos, you understand that to get rid of the root sign, the 3 must come and divide into the power inside there, like this. Now I'll take 4 to the other side. So I have 2x squared y equals 3x power 7 over 3 minus 4. Now I'm going to divide by 2x squared throughout. Term-wise division coming up again. This will be y equals 3x power 7 over 3 all over 2x squared minus 4 all over 2x squared. This part here will be y equals, simplifying that, if you like, 3 over 2, and then x power 7 over 3 minus 2. The answer is 1 over 3. Let's check this. 7 over 3 minus 2. The answer is 1/3. There it is. So power 1 over 3. Here you're going to have minus 2 x power minus 2. Take the x power 2 up. That's what you're going to get. Now we can perform the differentiation. So dy dx is going to be equal to this one here. Leave it the way it is, but multiply that by 1/3, x power 1/3, reduce it by 1, minus 2 multiply by minus 2, x power minus 2, reduce it by 1. Simplifying this part here, you're going to get 1 over 2 x power minus 2 over 3. 1/3 minus 1 is minus 2 over 3. And then you're going to have here plus 4 x power minus 3. Under normal circumstances, this is where you're supposed to stop. But otherwise, respecting the format in which the question has come, I would present this, and I'm gonna, because of space, I'm not gonna put too many steps here. So please verify this. It's gonna be 2. Remember, this one here is square root of x cubed. I mean cube root of x squared, this part. If it comes down here, it will be cube root of x squared. So 2 cube root of x squared. And then I have plus 4 over x cubed. Please verify this one here. Otherwise, I would have another step there, but I've decided because of space, this should be sufficient. Remember, when this one comes down, it becomes positive 2/3. What does it mean? 3 is dividing, so it's cube root of x squared like this, but there's a 2 here in the denominator, so you have that as your final solution. Now, how are the marks distributed? Where you have 1 mark for it's how many marks? 4 marks. So I'm going to give 1 mark for this part here, 1 mark for that, and then 1 mark for this part here, and 1 mark for that. Like I told you, you don't usually get a mark for the last part here, and unless the question specifically says that you must leave your answers with positive powers of x, then you would have that. So this is the question you had there for 4 marks. I am going to stop here. 30 minutes plus some seconds. I'm going to stop here. We'll bring up another question like I promised. Just one question to go through, and then move on to university stuff. All right. If you're new to the channel, please help us by subscribing, inviting friends to subscribe. Let's share these videos and support us so we can support you academically. All right. See you next time.